Hello everyone, Swagatam, and once again all of you are pretty welcome over here at the channel of PW. My name is Aman, your favorite maths buddy, and today I am over here to help you revise the chapter of coordinate geometry. To me, this chapter is the easiest chapter of among all of the chapter we have in grade 10. So we'll have a lot more fun understanding this easiest chapter, and before that I would like to mention that please make sure that along with me you also solve few of the problems and take the notes of all of this, because whole idea behind the revision is everyone is comfortable, right? So on that note, let's start the coordinate geometry over here. The name itself is comprising of geometry. So what is about geometry over here? It will be dealing with the shapes also. How so? Since we have in the previous time when we meet, we had talked about triangle. In that particular case, triangle, that was geometry. Yes, it was very obvious that we were having three sides figure and we were talking about polygons and all. But in coordinate geometry, how we talk about shapes? Over here, we'll be drawing shapes on the piece of graph paper. And this is basically coordinate geometry, is the relation between algebra and geometry. I'll once again reiterate, relation between, this is a relation between what? Geography, not geography, this is geometry. So algebra and geometry, algebra and geometry. This is what we do. This is what we do in the case of coordinate geometry. Now this is not exactly new, you have already learned, but anyhow I would like to revise things for you. How would I like to revise things for you? What exactly are coordinates? What is a Cartesian system? We are going to talk about what is a Cartesian system, and then we have two important topics, one being the distance formula, another being section formula. Leave apart the section formula and the distance formula. We are not talking about the formulas at the moment. We are talking about the concept. What exactly is a Cartesian system? What are the coordinates and so and so. This is very easy to understand. I have a very obvious example over here. This can be understood. Today, if you want to visit to some place, what you'll be doing? You'll be simply typing in your Google Maps and looking for how much distance it have and what are the possible means to reach that particular place. But that was not the case every time. For example, at the moment on this particular board, if I have put up a dot over here like this, I have put up a dot over here, and I ask you to put up in the comment box where does it lie on the piece of board over here. So different answer I'll be receiving. What kind of answer? Someone would be saying, sir, it is on the upper side of the board. Someone would be saying, sir, it is on the left side of the board. Someone might be saying, sir, it is towards the corner, sir. Yeah, all of them are perfectly right, but that doesn't define it exactly where does it lie. So there should be some parameter through which we can exactly define where does it lie, or the lying part, or I would say the location part, the most important thing, can be quoted by some coordinates. The coordinate is nothing new. If we have watched any war movies, they talk about, copy that, I have the coordinates, I have the terrorist in my eyesight, I can shoot him right now. So coordinates indicate the exact location of something, exact location of something. So that is the reason I quote the example if you visit some place. So earlier we used to use maps. Now we have that flexibility that ahead of maps we had Google, right? Now initially we were having only maps. We used to open up a 2D chart which used to tell me that okay, this much would be the location, this would be the location, and this is the distance you would be having to travel. And that particular maps used to have coordinates. And what kind of a coordinates? They would be having two different dimensions, two different details which used to pinpoint on the piece of paper exactly where I need to travel, So for this particular slide, they will say that okay, if I have a particular reference point, so from this reference point somewhere on this side, what will be the coordinate, and somewhere on this side, what will be the coordinate, and using the 2 points, using the two different dimension, I'll be able to pinpoint exact location. So few things are becoming clear. What's coordinates are simply helping us with the location of anything, right? And we need two dimensions over here to exactly define the location of any particular thing, and this particular thing should be on a 2D plane. This exactly we are dealing with the 2D plane. This is also important. 2D plane is the thing which we are dealing with. 2D plane, I would say over here. Now, as I mentioned, how we proceed further in this particular thing, things are quite simple over here. There was a mathematician whose name was Descartes. a mathematician whose name was Descartes. The name itself is Descartes, and that is why Cartesian plane. That is why Cartesian plane. So he was having his leisure time. These days leisure time is by watching some reels or watching something else, spending some time watching something, consuming some kind of a content. But earlier you have to create your own content. And while he was lying on the bed, he was just looking up towards the wall and thinking about, okay, how would I pinpoint that particular location, so and so. And he came up with a Cartesian system. What he defined over there, he simply defined that, let's say I'm having two different axes. One is a horizontal axis like this, one is a horizontal like axis like this, and another axis would be there which will be vertical axis like this. Since this is horizontal and this is vertical, the angle between these two axes would be 90 degree. The angle between these two axes would be 90 degree. So he told that, okay, two dimensions would be there, a horizontal one and the vertical one, and the 90 degree angle would be there in between. And this plane coming up like this, would be called as a Cartesian plane. This would be called as a Cartesian plane. Cartesian plane. Cartesian plane, what do we have in Cartesian plane? We have two axes. We have horizontal axis. What are the two dimensions? We have a horizontal one and a vertical one. And in both the cases, we will be defining some reference point. We'll be using it as x-axis, we'll be using as y-axis, and both cutting each other at an angle of 90 degree, intersecting at 90 degree. Fair enough. And this particular point is our reference point. This is 90 degree and this is our reference point. So ultimately we came up with a proper system, and this is how the system looks. You have seen on a piece of graph paper what we do. We draw a horizontal line which we call as x-axis, and horizontal line is similar to the number line which we draw. Number line, I hope this much you would be remembering from your previous grades. You have to plot a rational number, you have to plot a whole number, integer, on a number line. So on a number line we have a 0 as a reference point. From 0 we go on the right hand side, and on the left hand side. So positive and negative, two different directions are there. So this basically is being indicated by negative x-axis and positive x-axis. Two different axes, two different directions are there on the same axis, x-axis, one being negative, another being positive. Right side of 0 is the positive one and left side is the negative one. Same happens in the case of vertical, and we gave a name for the vertical as y-axis, upwards. Always upwards is good. We assume that upward is always good. So that is positive. Going downwards is a negative over here. So this is negative y-axis. This was positive y-axis. As I mentioned, there will be an intersection happening at a point which we call as reference. This reference point is called as origin. We call this as origin. From here everything originated. So ultimately origin is having a coordinate 0, 0. As I mentioned, there will be two things. There will be 2 points which will be defining everything. This will be defining everything. And in this manner it will be working. How so? This will be defined as x, y. So we will be having some first unit which will be defining the dimensions in terms of x, the coordinates of x, and the second thing, the dimensions of y in terms of y coordinates. So how? This will be very simple. First of all, this basic detail should be very clear that we are using a Cartesian plane which is made up of two axes. X-axis a horizontal one, y-axis a vertical one, intersecting at a 90 degree angle at a point which we call as origin, which we are taking as a reference point from where everything is starting, and that is why we are having 0, 0 as its dimension or its coordinate. Fine. These are the basic things. So in the cases of x-axis, we are having a positive one, a negative one, y-axis positive one, negative one. Now, since we are having a positive and negative one, so whenever we have plotting a point in one direction, let's say I'm plotting a point in this particular plane, in this particular segment, since we are having a 4 segments, now we have a 90 degree angle. So this is one quadrant, this is second quadrant, third quadrant, fourth quadrant. If your English is fine, things will be simple for you. Quadrant basically makes up 90 degree. If a circle is having a quadrant, so 90 degree is the angle which is making up a quadrant. So over here, this is one quadrant, second, third, fourth. In this anti-clockwise direction we are moving, not clockwise. We will be very smart, sir, clockwise. No, not circular, it's anti-clockwise like this, anti-clockwise. First, second, third, fourth. Four different parts we have divided. Now, in this particular case, we have to observe there is a sign for each quadrant. How? As I mentioned, here is one point which I have plotted. Here is one point which I have plotted. So as I mentioned, there is coordinates, x coordinate and y coordinate, which will be defining this particular point. So x coordinate and y coordinate. X coordinate will be having some positive value. Why, sir? How do I know? I know because this is lying on the right hand side of the zero, right hand side of the origin, on the right hand side, so everything is positive. In the case of y also, if you observe, it is lying on the upward side of y. So again, this will also be positive. So this is positive, and that is why they have quoted in the first quadrant all the points lying would be positive, comma positive. This is nothing which needs to be mugged up at the point you should be noting in the notebook, but that doesn't mean that you have to just mug it up. I hope you have understood why it is happening. The first quadrant will be having the x coordinate and y coordinates both being positive. Then going further, second quadrant. In the case of second quadrant, we move on the left of 0, on the horizontal axis, and hence if we are having a point over here, so this point x comma y, so x will be negative. Why? Because on the left hand side. But since this is on the upwards of the origin or x-axis, so y coordinate will still remain positive. Minus plus is the sign of the second quadrant. All the points in the second quadrant will be showing this sign, minus plus. Third quadrant, any point in the third quadrant will be having x comma y coordinate will be what? Since we are on the left hand side of the x-axis and below our x-axis this time, so both the things become negative. Easy way of remembering the sign is that the first and the opposite of it are having the same signs. What same signs, sir? One is having plus plus and this one is having minus minus. Plus plus, minus minus, first and the third one. Second, minus plus. In the case of second, minus comes first. So initially we should be thinking that plus should be coming first. No, minus comes first, and then in the fourth quadrant positive come, then we come negative. So once again, if I have to reiterate what we have learned till now, we have learned few basic things: x-axis horizontal, y-axis perpendicular axis, making a 90-degree angle, meeting at 0, comma 0, which is origin, and we are having four quadrants: 1, 2, 3, 4. Positive, positive, negative, 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 positive, positive, negative. This much you should be remembering by now. And coordinates, why are we learning at the first place? Because indicate the location of any point. And secondly, what is coordinate geometry all about? Coordinate geometry is all about the relation of algebra with geometry. And thirdly, most importantly over here, we are dealing in a Cartesian plane because Descartes gave this system to us. This much was the basic. Now, what we have learned in the previous grade, if we are having a point P which is x comma y, so how does it occur over here? So first of all, we'll be moving on the horizontal axis, that is x-axis. First movement should be on the horizontal axis always. Always we have to move on the horizontal axis, whatever the x coordinate is. So x unit movement we have made over here. Then we have to check for the y coordinate. If the y is positive, we'll move upward. If y is negative, we'll move downward. Same happens with x-axis as well, x coordinate as well. If it is positive, we'll go on the right hand side. If it is negative, we'll go on the left hand side. If y positive, we'll upward, otherwise downward. So we have moved x units on the right hand side. Now y units, we'll be moving perpendicular to x-axis and parallel to y-axis. Not exactly on y-axis, but perpendicular to x-axis and parallel to y. This is the important point. Parallel to y. So I moved like this units, and we reached to this point x comma y. So important thing is what? First we'll move on the x part, and then we'll move on the y part. And in this we have already told positive, so go on the right, negative, go on the left, positive, go on the upward side, negative, go on the downward side. Few basic things. Fair enough. Now, understand one more thing over here. If the point is given P, x comma y, if someone asks you, sir, what is the distance of this point? From x-axis. Many of the students will be very quick to answer, sir, the x coordinate is the distance from x-axis. No, bache, no. Just have some patience and observe the given figure carefully. I told you from the x-axis we have to move perpendicularly. How many units? Y coordinates, that means y units. So y coordinate will be telling you that how much distance it have from x-axis. Y coordinate tells you the distance from x-axis and x coordinate tells you the distance from y-axis. So if I have to write it down, y perpendicular distance from x and x coordinate perpendicular distance from y. What x and y? X-axis and y-axis. This is what I am indicating. And this is all the basic we have. Ultimately, there is a name given to all of these. The name given to this is x coordinate is called as abscissa and y coordinate is called as ordinate. Yes, simply ordinate, not coordinate. It is simply ordinate. So don't get confused if someone is asking after giving you a question, tell me the abscissa for this particular thing. That means they're asking the x coordinate. If they're asking ordinate, that means they're asking the y coordinate. So these are the basic things which you have to mention clearly over here. Once we have mentioned all these things, then we can proceed further, and this thing I have already mentioned, x comma y. So y is indicating the perpendicular distance from x and this x coordinate is indicating the perpendicular distance from y axis. All the things mentioned, first move on the x axis, then perpendicularly or perpendicularly upward or downward. This is how we proceed further. These were all the basics we had. Now let us take up a few very simple and easy questions to understand whether you have realized something or not. So here we have the first question which says, what are the coordinates of R? Always there would be a graph given and you have to check whether you are able to understand the coordinate. If you are seeing a map, you should know the basics of the map, how to locate any particular point. If you are sitting in London and you want to reach to New Delhi, so New Delhi should be perfectly coordinated over there, that okay, this is the latitude and longitude. These are the points used in geography for the coordinates. These are the points used in geography. I hope you are learning some social science as well, and that was the reason this very starting I somehow blundered over there saying that it is a relation with geography. No, it is not with geography but with geometry. We are dealing with shapes over here. It doesn't seem like, but yes, we are. Coming to the point over here, the R is x comma y and they have given me the perpendicular distance. There are multiple ways of seeing this part. First, as I mentioned, the perpendicular distance from y axis will give you x. This will give you x. So x is how much? X is -4. And this perpendicular distance will give you what? This will be giving you y. So this is basically 3. How so? This is basically a rectangle form. So whatever the distance, this much will be. So the same distance here will be having. So this is 0 to -4. So -4. This is 3. Why? Because this much is 3. So initially to reach this point, we moved -4 units. So -4 is the x coordinate. Then we moved perpendicular to x axis and parallel to y axis. How many? 3 units. So -4, 3. -4, 3 is the coordinate of this point over here, which is R. So R is indicating that -4 is the perpendicular distance from y-axis and 3 is the perpendicular distance from x-axis. Very simple thing. This two things should be very clear: how to plot a point and how to find the coordinates of the point. If this much you don't know, you should pause the video, rewatch again, then go forward. Otherwise, no need to go forward. Next question over here. They are asking about the quadrant. Since we have learned about the quadrant, it says the point which abscissa and ordinate have different sign will lie. If you remember, I gave you the hint how to remember. The first quadrant and the third quadrant, the opposite one, first and third one have the same sign and rest of the two have the opposite one. So answer is quite obvious over here. Which one? So the second one and the fourth one will be having the opposite sign. The second one will be having what? Second one will be having negative comma positive, and the fourth one will be having what? It will be having positive comma negative, and that is what we have to remember over here. So these are the basics over here, very simple. And one more question, okay? All right, over here we have, it says point -5, 3 lies in which quadrant? So either you plot that particular point, and I don't believe that over here you need to follow the long method over there. Simply by checking the sign itself, you can always find out the coordinates. So what are the signs given over here? Negative, positive. Just now we have checked negative, positive lies in which quadrant? Second quadrant. Very simple. Even if you want to go by the long method, you'll realize very early you are having -3. So you'll go on the left hand side on x-axis. Then you will move perpendicularly upwards like this. So then you will be reaching -5, 3, which is lying in the first, then second quadrant. So answer is option number B over here, second quadrant. Things are quite simple, right? One more question, one final question, and then we'll move ahead. Then we'll move ahead with the basic part. And here we have the final question, which says the point whose ordinate is 6 and which lies on y-axis. Whose ordinate is 6 and which lie on the y-axis. Think about it. One important thing which I didn't explicitly mentioned over here was that if we are having a point which lies on the y-axis, so what will be the coordinate of it? You can imagine this very easily. If you are having a coordinate, if you are having this x-axis, y-axis, if some point is on x-axis over here, so what happened in this point? To reach to this point, we would have moved some units on the x-axis, fine. So x will be having some coordinate x. Then what about the perpendicular movement? Have we done any perpendicular movement? No sir, we haven't done. So since we haven't done any perpendicular movement, either upward or downward, it will be 0, x comma 0. Similarly, any point, on this point, it will be minus x comma 0. Here also, x comma 0, x will be having some value. I don't know at that point what is the value. So on the entire x-axis, this will be x comma 0. So one important learning from here, on x-axis, the coordinate will be what? X comma 0. Now think about the y-axis, sir. In the case of y-axis, when we have anything on y-axis, that means on the x we haven't done any movement. The first thing is to move on the x-axis, right or left? No, but we haven't done. We have then moved to upward y-axis or downward. So somewhere over here if we are, so there is 0 movement on the x-axis, so x coordinate would be 0. X coordinate would be 0. We'll be having some y coordinate. Or if downwards, we'll be having some negative coordinate or kya? And y will be having plus y or minus y. It totally depends, upward movement or downwards movement. Then that's it. So now coming back to the question which lies on the y-axis, so it will be having 0 comma y, and they have clearly mentioned over here the coordinate. Ordinate is what? Y coordinate. It is given to me as simply 6. So the point from here comes out to be 0 comma 6. Our answer is option number B over here. I hope you have no difficulty in this particular thing over here. A simple task. Going ahead to the next topic which we have in this particular chapter, which is known as a distance formula. Name suggests what we have to do. We have to find the distance between the 2 points. Alright. I talked about finding out the distance of a point from x-axis, finding out the distance from y-axis. Important thing was perpendicular distance is what we are dealing with. Always we look for the perpendicular distance. So this over here, the perpendicular distance from here, the perpendicular distance from here. But if I talk about two different points, let me talk about this particular point from origin. So this point, let it be 2 comma 2. 2 comma 2 is the point. Or let me take up 2 comma 3. Let me take 2 comma 3. Or y 2 comma 3, let me take 3 comma 4. 3 comma 4 over here. This is the point 3 comma 4 over here. And this is the point, second point which I am interested in, origin, that is 0 comma 0. I hope it is clearly visible. Now I want to find out the distance between these 2 points. So distance is what? The shortest distance which I am interested in. It's not like, okay, you will be traveling like this. This is the distance I am interested in. Or you go by this method. This is not how things work, right? So you have to move straight. You have to reach with the shortest distance. The shortest distance is this much. So in this particular case, if I take this point to be A, this point to be B. So how would I find A and B? AB basically. AB is the point which I need to find. AB is the distance which I need to find out. AB is missing over here. AB is the distance which is missing over here. To find out AB, look at the coordinates very carefully. How so? For A, we are having 0 comma 0. For B, we are having 3 units over here. And we are having 4 units over here. This much distance is what? 3. And this much distance is what? 4. Observing this part, 3 units on x-axis and perpendicular to x-axis 4 units. Or let me draw in black. I think that will have a better contrast and you'll get a better clarity. This is 3 and this is 4 over here. And another thing which happens over here is, I told you first on the x-axis, then perpendicular to x-axis. So the angle over here is 90 degree. And once I have told you that the angle is 90 degree, let me say it is point P. So triangle ABP. I believe all of us will agree triangle ABP is a right angle triangle. Right angle triangle. And in the case of right angle triangle, there is one theorem that is always and most of the time used by the name of Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. So it helps us to find the third side if we know any of the two sides. And I believe we know two sides. One is 3, one is 4. And the longest side is over here AB, which is our hypotenuse, which we don't know. So by Pythagoras theorem, if you don't know Pythagoras theorem, so listen over here very carefully. Pythagoras theorem says AB square, that means the hypotenuse square will be, hypotenuse is the longest side square will be equal to the sum of the other two sides square. Sum of the other two sides square. Other two sides means this one AP, this one AP square plus BP square. So when you do the calculation for this one, let me draw in the next figure over here so that you get a better clarity. This was 1 point and 3, 4. This was the second point. This was our point. This was A, this was B. So this is B over here. This is A over here. We had this triangle being formed. I was interested in the distance AB. AB is the distance I'm interested in. This is 3, this is 4, this is 90-degree angle. I told you AB square. I told you AB square will be equal to equals to AP. This is P over here. AP square plus BP square. We have AP and BP. So put up the values. AP is 3 square plus BP is 4 square. So AB square will be what? AB square will be simply 3 square. That means 9 plus 4 square, that is 16, that is 25. I believe 25 is what? 5 square. So AB square is equals to 5 square. So AB is what? AB is simply 5. We have used the Pythagoras theorem to find out the distance between these 2 points. And the same we are going to repeat for any 2 point. But the best thing over here was that this point over here, A was having a coordinate 0, 0. 0, 0, and that saved a lot of effort. Why, sir? That saved a lot of effort because in case if the point would have been over here and the point would have been over here. So in that case, to form a right angle triangle, like this, the distance would have been different. How so? If I say this is basically x1, this is x1, y1, x1, y1. All right, this is x2, y2. So in this case, what is going to happen? In this case, we are going to find out this distance. And this distance, how I'm going to calculate? This distance over here will be x2 minus x1. Basically, what is happening over here? This is the distance I want to find out. So I know this much distance is 4, let's say, or over here it's clear that it is 3. So and this distance over here is 1. This distance over here is 1. So to calculate this one, how would I calculate? I would simply write it as 3 minus 1, right? That is equal to 2. And the same thing I'll be doing over here. I'll be writing it as x2 minus x1. Similarly for this, it will be y2 minus 1, y1. This is the thing which makes it a bit different when dealing with the origin. When we were dealing with origin, it was 0, 0. But when we are having 2 points which are not at origin, then the distance will be changing. So ultimately, when we use the Pythagoras theorem and come up with a distance formula, it looks like this. This is the distance formula which looks like. Or in the previous case itself, if I use the Pythagoras theorem, it would have been very simple. If this is A over here, oh, everything is gone. Rather than calculating, everything is gone. So this is A, which is having the coordinate x1, y1. So over here for this particular case, if I say this is A, this is B, and this is P, so again by Pythagoras theorem, we would have reached to AB square is equals to AP square plus BP square, and over here again putting up the same things, you would have come across as AB square, which will be what? X2, not square anymore. AB square would have come out to be x2 minus x1 whole square plus y2 minus y1 whole square. And why, sir? I told you already. The reason is very obvious. This distance is x2 minus x1. This distance is y2 minus y1. So square of this plus square of this. square of this being added, and since we find the AB, not AB square, so square root comes above this one. Ultimately, you can take a screenshot, you can write it down. This is the ultimate formula which we are going to use again and again and again. I gave you the origin, I gave you the explanation. How do we get this formula? How do we get this formula? And I hope you are getting a realization. Now, these equations basically are what? They are algebra, and we are dealing with lines, we are dealing with shapes over here, triangles and all. These are what? These are geometry, and hence algebra plus geometry make up coordinate geometry. So if you have noted down this formula, then we can proceed further to solve few problems on this. And here we have the first simple problem asking you to calculate the distance between 2 points. So 2 points are given. The first thing you will be doing, first learn the very basic, and once you are equipped with that, helpful thing would be for you that you will be directly putting up the formula without thinking anything. In the few starting problems, take some time, be accustomed to the thing, So over here, see x1 comma y1, is for you over here is 2 comma 3. So x1 value is 2, y1 value is 3. x2 comma y2 will be what? x2 comma y2 will be 4 comma 1. So how will we calculate the distance? Distance is under root x2 minus x1. That means the difference. Either you can take x2 minus x1 or you can take x1 minus x2. But same you have to repeat in y case also. You have to take difference ultimately. Whatever difference you are taking over here, the same difference should be there. So remember, in this manner only, x2 minus x1 square plus y2 minus y1 square. Alright, so put up the values now, things will be very simple. x2, that means 4 minus 2. So 4 minus 2 whole square. y2 minus y1, that means 1 minus 3 whole square. So over here, 4 minus 2 is what? 4 minus 2 is 2, so 2 square plus 1 minus 3 is what? Minus 2 whole square, right? 4 minus 2 is 2, 1 minus 3 is minus 2. So over here, does it make any difference? Plus 2 square or minus 2 square? I don't think so. They both are the same thing. So ultimately 4 plus 4 over here, you can write 8, or in the square root, it is 2 root 2. That is our answer. Important thing. You can go forward checking for x1 minus x2, y1 minus y2. But whatever the relation you are taking on this side of x, you should be taking the same on the y case also. You will come up with the same answer. No difference will be there. Simple application. Formula, if you remember, just remember which is x1, which is x2, which is y1, which is y2. Things will be very easy and smooth for you. Going further. Now, what exactly is section formula? If you remember in your classrooms, if you are grade 10 student, you would be having different sections. Like for example, in my class, it was section A, section B, section C, like this. There are other names given to different things, but section ultimately is a division, some form of division, right? So what kind of a division are we dealing with over here? Over here, what we are doing, let's say we are having a point over here A, this is point A, and this is point B, So this line AB is there. What is going to be done over here? There will be a point, this C. What this C will be doing? This C will be dividing A, B into two different parts. Now, this part will be having some ratio. Let me, this ratio is M and this ratio is N. Now, we have to somehow find either the ratio in the problems, or we have to find the coordinates of point C. This is a thing which they can ask in the examination. So for that, we have a section formula, but ultimately you have to realize how do section formula derived. The section formulas also have the same derivation as of the distance 1. We have different triangles being formed, and they all will be using the Pythagoras theorem to get the coordinates of C or the ratio part. Ultimately, Pythagoras theorem will be very, very useful. So when we do everything over here, what will be the final thing coming up over here? The final thing coming up over here will be this, that the coordinate of the point which will be dividing the line AB in M ratio N. Two ratios, that is M over here, this is M ratio N. This will be mx2 plus nx1 divided by m plus 1. This is simply x coordinate, and the similar nature will be having a y coordinate. Now, compared to distance formula, you might say, sir, this seems to be complicated. No, it's not complicated. It's all about the application. More the problems you do, the better comfortable you get in this particular case. So why waste any more time? Let's do the problem on this. But few things should be very clear. What few things? First of all, it is mentioned over here that it is internal section formula. Internal section formula. Sir, is there an external section formula? Yes, it is. It is. But at the moment, it's not in your grade. You'll be learning in this if you are more interested in mathematics and you take up mathematics in the grade of 11th, you'll be learning about external section formula. And external over there simply means that internal, this point was lying somewhere internal. External means that the point will be lying external and then they will be having some ratio. So don't bother that much. For activity, you can think about it. What does external mean and how does the ratio work over there? But internal over here simply means that the point will be lying between the 2 points. And will be dividing in the ratio m and n. Alright. And second thing which I would like to mention over here. Let's say C is a point which is dividing A and B into equal parts. C is a point which is dividing A and B into equal parts. So what would happen? In that case, m ratio n. What would happen to m ratio n? M ratio n. I think ratio part is clear. The ratio is what? The comparison of the two quantities, right? So m ratio n would be what? 1:1. Both will be same because m by n will be 1, right? When you divide the two things, they will be same. When this happens, you replace m and n on all the cases by 1, 1, 1, 1, 1. And you come up with a new formula. What is that new formula? The new formula is that the coordinate x comma y of that particular point will be simply x1 plus x2 by 2, comma y1 plus y2 by 2. And this formula is known as midpoint formula. And for few, you might be thinking, oh, such a easy and good to go formula. This is not a new formula. This is just a simple addition of the section formula. Nothing new happening over here. You have just put up the things. When do we have to apply midpoint formula? When the point is dividing the line into two equal parts or the ratio is clearly mentioned 1:1. And then you'll be using the midpoint formula. I hope you are getting the clarity. For section formula, you might be having the confusion, but the confusion can only be sorted out by solving few problems. So let's solve few problems without wasting any more time. Here we have the question which says, find the coordinate of the point which divides the join of this point and this point. And important thing, listen, section formula can also be easily understood. Let's say you are traveling from Delhi to London. I hope you have a good sense of geography. So if you are traveling from Delhi to London and you are having a layover at certain place, your flight is taking off from Delhi, but it's not directly reaching to London. It's going via certain place. Let's say it's going via Dubai. So Dubai is a point between the distance of Delhi and London. So if someone asks how Dubai is dividing the two different travel distance or time also, over here we are concerned with the distance. That how much distance over here and how much distance over here, and when we take the comparison, that means when we divide, what ratio will be coming up? The same thing. So over here the coordinates of the point, let's say this is point A and this is point B. So for A and B, we are having the ratio. M ratio n is 2:3. So let me first of all clearly mention over here what all is given. A is given to me as -1,7. B is given to me as 4, minus 3, and M ratio n is given to us as 2:3. So you have the value of m is equals to 2, n is equals to 3, x1 is equals to what? -1, and x2 is equals to 4, y1 is equals to 7, and y2 is equals to -3. This is all I have written just for your understanding. There will be no need. Once or twice you'll be writing it. After that there will be no need. It will be a waste of time. You will not need anything. You will not be taking these minute steps. You will be directly applying the formula. What is the formula? Come to the section formula. So the coordinate of that particular point, let me call that point C. So the coordinate of C will be x, y. It will be what? It will be simply mx2 plus nx1 upon m plus n. Right? So m being multiplied with x2. So you must remember, let me show you in case you are having any difficulties or how to apply it. In the case of midpoint, in the case of section formula, m is this ratio. So this will be multiplied. M would always be multiplied with the other x. M would be multiplied with the other x over here and would be multiplied with this x over here. In this way you can remember, m would be multiplied on this side, so it will be multiplied with the x coordinate of other point, which is farther than the first point, and similarly n would be multiplied with a further point. So always multiplication happens with a further point over here. So m with y2 and n with y1. So m closer to x1 but it will be multiplied with x2, and closer to x2 but it will be multiplied with x1. This is one way of remembering it. Ultimately there is a proper way of doing it. So as I mentioned, there is no need to remember that much, because as much you practice, the better you get over here. So we have written the formula. Let's now put up the values. Let's put up the values. For x coordinate we have written, similarly for y coordinate we will be having my2 plus my1 upon, not m, this will be n over here, this will be n over here, plus n y1 upon m plus n. So over here, putting up the values simply, m is what? M is 2. So 2 into 4. 2 into 4. We are having x2. x2 over here is 4. 2 into 4 plus, what is n? N is given to me as 3. So 3 will be multiplied with what? 3 will be multiplied with x1, that is minus 1. So 3 into minus 1. And we are having m plus n, that means 2 plus 3. Same will be doing for y coordinate. In the denominator we will be having 2 plus 3. First we will be multiplying 2 with what? 2 will be the y2. So that means minus 3, 2 into minus 3 plus 3 into y1, that is 7 over here. Do the calculation. Rest of the things are very simple. 2 into 4 is 8. 8 minus 3 upon 2 plus 3 is 5. This is 2 into minus 3, that is minus 6. Minus 6 plus 3 into 7, that is 21 upon 5. So we are having 8 minus 3, that is 5 by 5. 5 by 5 over here. And over here 21 minus 6, that means 15 by 5. The answer over here coming would be what? The answer coming over here would be 5 divided by 5, that means 1 comma 3. 1 comma 3 would be the point which will be dividing AB in the ratio 2:3. The calculation are as usual. After this, no need to apply your mind. The only thing is how to put up the values. That is the important and the crucial step in this problem, which you have to be very careful about. I hope you are getting this point. Only this is the thing which we have to do in section formula. Just like in the distance formula, we have to apply formula. In the case of section formula, we have to apply formula. There might be a framing difference. There might be a framing difference of the question. Other than that, there will be no difference at all. Alright, so let me show you a different set of question, different kind of category of question which can happen to be there. Alright, this is the one. This is the one. Find the ratio in which the line segment joining the point, this is A, this is B, is divided by C. This is C. So A, B, C all have been mentioned. All have been mentioned, A, B, C. And as you know that the coordinate of C, 1, 6 are written how? They are written in the terms of mx2 plus nx1 upon m plus n. And for the case of y, same thing applies, m plus n, and m multiplied with y2 plus n multiplied with y1. Now, we don't have m and n over here. We don't have m and n over here. We need to find the ratio. We need to find the ratio. How would I find the ratio? Now, whenever we need to find the ratio, don't consider ratio to be m and n. Things will get very complicated for you. The easier way to find it, is always going by assuming the ratio to be k ratio 1. Assume m ratio n as k ratio 1. Things will be simple. Things will be simple. You will realize when you take the ratio to be k ratio 1. We are assuming that the ratio is k ratio 1 and we don't know k. Because if we would have taken m and n, we would have two unknown. At the moment, we are having only one unknown. That's it. That's it. So going forward, apply this particular formula. So in denominator k plus 1, in denominator k plus 1, k being multiplied to 6, k into 6, that is x2 plus 1 being multiplied with minus 3, so 1 into minus 3. In the case of y, again k plus 1, so k being multiplied with over here minus 8, k being multiplied with minus 8, that is y2, and 1 being multiplied with 10, that is y1. Now, what we need to do? This is x coordinate, this is y coordinate. I have the x coordinate and y coordinate. X is minus 1, 6 is the y coordinate. I can equate x with x, y with y. And that is what I have to do. I'll equate x with x. So equating over here. When I equate minus 1 to this part, k into 6, 6k plus. Not plus, it will be minus. minus 3 upon k plus 1. So I'll be doing the cross multiplication, and I believe this will form a simple equation which can be easily solved. So k plus 1 is equals to 6k minus 3. So from here what I'll be having, this k will be going on this side, so 6k minus k, that will be 5k. This will be going on this side, this will be going on this side, so minus 3 will be coming on this side, plus 3 plus 1 4, k coming out to be 4 by 5. And you can find out this value by equating y coordinate as well. Equate the y coordinates. You will get the same thing. You will get the same things after equating the y coordinates. But is it the final answer? No, this is not the final answer. We assume that the k ratio 1. We have the value of k ratio 1 now at the moment as 4 by 5 ratio 1. So for this particular case, when I multiply both the ratios by 5, I'll be having what? 4 ratio 5. Right? This is the case. This is the answer over here. So in the case, wherever we need to find the ratio, always take the ratio to be k ratio 1. This is what we have to assume. I hope you are getting the clarity over here. This is the most important thing which you have to be very, very careful. So among this, one final question which I'll be giving it to you. You have to solve it for me. The question will be this one. Find the coordinates of a point A where AB is the diameter of the circle whose center is given. So this is a circle. The center is given to you, and B is the point. So B is the point, center is given, A is the one which we need to find. B we have. So what will be the relation between A, B and C? The relation will be that C is the center point. You have the center point. That means you can use the midpoint formula. So this is a problem for you, and these kind of problem would be relating circles, different parallelogram, rhombus, square, rectangle, all this kind of a relation would be there. So this is a homework question for you. I believe whatever answer is there, please write in the chat box, not over here the chat box, it's the comment box over here. Answer in the comment box below. So that is all what we have in this particular chapter. We have used everything what we had. We have basically three things: section formula, distance formula, and the version of section formula which is midpoint formula. I hope you have the clarity. I gave you the homework, solve it and practice all the textbook question which you have. So meet in the next session, and I believe you will practice more and more. Till then, have a great time. Enjoy yourself. Take care. Bye bye.